In this video, we will show you how to make an LED surface source property with an asymmetric angular distribution. To do this, we will use the Surface Source Property Generator utility in TracePro 7.0 and the LED datasheet. If you have not had a chance to view our previous video on making an LED surface source property in TracePro, I would suggest you do so first before viewing this video. To make our LED surface source property with asymmetric angular distribution for TracePro, we will be using the Surface Source Property Generator utility. You can launch the utility from the Utilities menu in TracePro 7.0. We will also be using an LED datasheet to make our property, in this case an Osram Golden Dragon with a lens. In particular, we'll be using the spectral distribution graph and the angular distribution graph. Here's an example of the spectral distribution graph for this LED. And here's the angular distribution graph, showing different angular distributions for the horizontal and vertical axes. We can now define the spectral properties for our LED. First, we'll click the Helper button here in the Wavelengths Editor window, opening up the Spectrum Input Helper. Next, we'll cut and paste the spectral graph from the LED datasheet using the Windows clipboard, and we'll paste that into the Spectrum Input Helper. We'll do a right click and then paste. Now we need to define the limits of our graph using setref1 and setref2. Our graph goes from 0.4 microns to 0.7 microns and from 0 to 100%, or from 0 to 1. We'll enter 0.4 microns and 0 for set reference 1 and 0.7 microns and 1 for setref2. We'll then click the setref1 button here and place a point right at the 0.4, 0 point here in the lower left-hand corner of our graph, a left click. Then we'll choose Set Reference 2 and place a point in the upper right-hand corner of our graph at 0.7 microns and 1. Now we can trace the LED spectral curve by left-clicking on it and defining a series of points. What we're looking to do is get a nice fit of the green curve to the LED spectral curve. Once you're satisfied with the fit of the curve, you can define the number of sample points for the property. In this case, we'll have 50 sample points. Then we can click the Sample button here, and we can see the results of our curve over here in the Results window. We've now finished defining the spectral properties for this LED property. Now we're going to define the angular distribution for our LED surface source property. First, let's close up the Wavelengths Editor window and move it out of the way. And now let's expand the Beam Shape Profile Editor. We are going to cut and paste the angular distribution graph from the LED datasheet into this window, very similar to what we did in the Wavelengths Editor. So let's take a look at our LED datasheet again. This graph, you can see, has both a polar graph and a rectangular graph. In the previous video, we used the polar distribution graph, but for this video, let's use the rectangular distribution graph. And as you can see, there is different profiles for both the horizontal and vertical angles. So first step is we will cut and paste this to the Windows clipboard. And then here we have the option of either polar or rectangular coordinate system. As we mentioned, we're going to use the rectangular graph, so we'll switch this to rectangular. Then we'll do a right click and choose Paste to paste the angular distribution graph into our beam shape profile editor. Now we need to define the limits for our graph. To do that, we'll use the Set Ref 1 and Set Ref 2 buttons here. For Set Ref 1, we want to set the angle to be 0 and the value to be 0. And for Set Ref 2, we want to set the angle to be 90 and the value to be 1. This corresponds to the lower left-hand corner and the upper right-hand corner of our rectangular graph. So click Set Ref 1, bring your cursor over here until it's at 0 degrees and 0, and left click to place a marker. Then click Set Ref 2, go here to 90 degrees and up to 1. Again, left click and leave a marker. Now we can start to define the angular distribution for this LED by tracing these curves. Since this LED is asymmetric in the azimuth angles, there's two curves, one for the horizontal and one for the vertical angles. We're going to do the horizontal angles first. And to trace this curve, we're just going to left click along it here so that this green curve follows the original LED curve. Once you're satisfied that the green curve fits your original curve, you can stop adding points. Now that we've defined the curve for our horizontal profile, we need to define the curve for the vertical profile. The first step is to go over to the Angular Profile Selector window. You notice as of now we only have a single angular profile defined, which we use for the horizontal profile. To add a second angular profile, we'll type in 90 here, since the vertical angles are 90 degrees away from the horizontal angles, and click Add. As you can see, that clears the data for the horizontal slice here, and allow us to go in and left click along the vertical slice in the exact same manner we did for the vertical to define this curve. Once again, once you have a nice fit to the curve, you can stop entering points. Now that we've finished entering our horizontal and vertical profiles for this LED surface source property, we can close this window up a bit and take a look at the 3D preview window. The 3D preview allows you to see a three-dimensional representation of the angular distribution for the LED surface source property. In this case, we are still set at our 90-degree angular profile. We can see the profile defined here in the 3D preview viewer, as well as over here in our beam shape profile editor. If we switch our angular profile back to the 0 degrees, which we used for our horizontal data, we can see that angular profile here, as well as our data back here in the beam shape profile editor. We've now finished entering the angular distribution data for this LED surface source property. The last step in the process of defining our LED surface source property is to export the property to TracePro. If we choose Export in the menu bar of the Surface Source Property Generator utility, we can open up the Export to TracePro dialog box. First, we need to define a catalog name. In this case, we'll use Video Example. Now we need to give the property a name. We'll call this Asymmetric LED. We can also enter a description for the property. We'll put in "this is the video LED." The number of azimuth angles for the property can be defined here. In this case, we have it set at 18, so there'll be 18 azimuth angles between 0 and 360 degrees. The number of polar angles is defined here. We have a setting of 30, so we'll have 30 polar angles between 0 and 90 degrees. The temperature is set at 300 Kelvin, and we have the emission set at 1 radiometric watt. As I mentioned in the previous video, you want to make sure these units agree with the units in your spectral data. Usually using watts is a safe choice. And then the last step is to click Export to export the property to TracePro. Now we can go into TracePro and take a look at the property we've defined. As you can see, the message macro window has been opened up, and there's a small #T displayed here. This means that the property has been successfully imported into TracePro. If we go to Define, Edit Property Data, and Surface Source Properties, we can then go to the catalog that we created, in this case Video Example, and we can come down to the property that we made, Asymmetric LED. We see our description here. This is the video LED that we entered in when we exported the property. Here's our polar and azimuth angles, our wavelengths, and our emissivity definitions for this property. And as you can see, we go from about 0.5175 microns all the way up to 0.6715 microns. Our polar angles go from 0 to 90 degrees, and our azimuth angles from 0 to 360 degrees. And then we see the emissivity values here for each wavelength, polar angle, and azimuth angle. Now let's apply our property to a surface in TracePro and check our results. We're going to open up a new model window, and we're going to insert a primitive solid. In this case, we're going to use a small block to represent our source. I'm going to apply the surface source property to this right-hand surface of this block. In this case, this is surface 0. If we right-click on surface 0 and then choose Properties and then Surface Source, we can open up the Surface Source Apply Properties dialog box. For emission type, we're going to choose Source Property. For Catalog, we'll go to Video Example, and for the name of the property, we'll choose Asymmetric LED. For the total number of rays that we're going to trace, we're going to enter 100,000. And for wavelengths, we'll enter 0.6 and then click Add. 0.6 microns is about in the center of the spectral distribution for this LED. The up vector settings control the rotation of the property, and we'll take a look at the effects of changing this up vector a little bit later. In the last step, click Apply to apply the property to surface 0. Now we can run our ray trace. Once the ray trace is complete, we can go to Analysis, Candela Plots, and Rectangular Candela Distribution to see the angular distribution of our LED property. We're going to right-click and choose Candela Options. We're going to set our normal vector to be z is equal to 1, so it's along the z-axis, which is the direction this source is pointing. And we'll set our up vector to be along the y-axis. And we'll also leave this selection here, Use Missed Rays, checked as is. And we'll click Apply. We can then go to the Candela Distributions tab here. We'll turn on Smoothing, and we'll change the number of horizontal angles to 2. And then click Apply, and close the Candela Options dialog box. We can now see the Candela plot for this LED surface source property. And if we go back here to our LED data sheet, We see this very large peak out around 60 degrees in the horizontal. And we see that very same peak. In this case, it's defined on the 90-degree axis. And here's our 0 degree or vertical data for this LED. Now we're going to take a look at the effect of changing the up vector in the Surface Source Apply Properties dialog box. First, I'm going to tile these windows so I can see them both at the same time. Now I'm going to choose Surface 0, do a right-click, Properties, and then choose Surface Source to open up the Surface Source Apply Properties dialog box. Now originally we had set the up vector to be along the y-axis, or y equals to 1, and here was our result. We have this large peak out here at about 60 degrees, and that's in the 90-degree profile. If we change this so that our up vector is now along the x-axis, click Apply, and run our ray trace. We can see that this large peak at 60 degrees is now along the 0 degree profile. So what we have done by changing the up vector is rotate the property 90 degrees about the z-axis. To wrap up this video, let's review the steps we took to make this LED surface source property. First, we used the wavelengths editor, and we pasted the spectrum from our LED data sheet. We defined the limits of our graph, and then we clicked along the curve to define the spectral curve for this LED. Then we used the cut and paste with the Windows clipboard to paste the angular distribution graph from our LED data sheet into the beam shape profile editor. First, we defined our horizontal angles by defining the limits of the graph, and then clicking along the curve to define the horizontal profile. Then we used the angular profile selector to define a second angle, 90 degrees from the first, and then clicked along the vertical profile to define our vertical angles for the LED surface source property. Then we exported the property to TracePro using the export command here in the menu bar. And then lastly, we went into TracePro, we applied the property to a surface, we ran a ray trace, and we looked at the results using the Candela plot. We'd like to thank you for attending our presentation. If you have further questions on our capabilities, please email us at sales@lambdares.com or call us at 978-486-0766. And please check out our other videos on our website. Thank you.